Okay, welcome to my first video on the world of Pytorch. Okay, so what I really want to do here is break down the key building blocks that make up the Pytorch library, right? So on the one hand, you have this thing called Pytorch. Now, Pytorch is really just made up of some fundamental building blocks. The first one to think about is called tensors. Okay, tensors. So this is pretty much like data structures in Pytorch, right? So you have NumPy tensors, but on steroids, right? So in Pytorch, it's the world of NumPy arrays, but with super fat powers, right? So fundamentally what happens is your images or anything or any data gets represented as a tensor. And how you get your data into a tensor is dealt with a tensor module. Now the second thing to look at, and the second major building block of Pytorch, is autograd. Okay. I'll come to what each one of these do in a minute. The third one is called NN, neural networks. Surprise, surprise. Right, so we're really in the world of deep learning, and deep learning is all about neural networks. So guess what you're going to be learning about in Pytorch, and how to create neural networks, and that's the domain of the neural networks module. Next major thing Pytorch is divided into, in terms of the building block, are loss functions. Okay, something called loss functions. Following on from loss functions, you have something called optimizers. And the last key one I want to mention is going to be, well, there's two more. Data loader. Okay, that's all about the world of data loading and data processing. And then there's, I think, three more I want to mention that make up the foundation of Pytorch. GPU. Okay, that's all about GPU acceleration. Okay, GPU acceleration. And then what else do we have? We have two more left, right? One is called Torch. Okay, so Pytorch has a foundation module called Torch, and something called functional. Okay, that's really torch.nn.functional, right? Okay, let me whisk through what each of these are. So you have 1 tensors, 2 autograd, 3 neural networks, 4 loss function, 5 optimizers, 6 data loader, 7 GPU acceleration, 8 torch, and 9 functional torch. Okay. So tensors we've been through. Autograd. This is just about keeping a track of what operations you're performing on your tensors, right? Now, why do you need this? This history tracking of what you're doing with your tensors allows you to calculate gradients. Okay. Now, what's a gradient? A gradient is simply how something is changing with respect to something else, right? Now, in the world of neural networks, gradients are a critical thing to look at and master, okay? Why they're important? Because as you know, neural network effectiveness is to do with the weights of each layer and how you adjust them. And the key critical thing that's used to adjust the weights in the neural network are gradients. So after that we have loss functions. So loss functions do something very simple, and that is they measure the error between what your model predicted and what actually happened in the real world, right? So loss functions are used to figure out the difference between the predicted error and the actual target values. Okay, so there's a couple of loss functions in Pytorch: mean squared error, cross entropy, etc. Now, one of the key objectives of neural networks and training neural networks is to minimize loss. Okay. The neural network tries to minimize loss. Right. So what that means is what you're predicting and what you get, the better your network's going to be, is if the loss value is lower and lower and lower, right? Because that means there's hardly any difference between what your model is predicting and the real world, right? And this is why loss functions are important in neural networks and training of neural networks, where the goal is to minimize this loss. Okay, optimizers. So optimizers basically let you figure out how you're going to update the model's weights, right? So weights are based on the gradients calculated, and optimizers let you figure out how to do the updates. So here's a couple of examples of optimizers: stochastic gradient descent, Adam, and RMS prop, whatever that is, root mean squared prop. So a couple of other ones of interest are going to be data loading and data processing, right? So within Pytorch, the dataset and data loader foundational module is all about how you load and organize your data sets for training and testing and batching for these, right? So data loading and processing is critical when you have massive data sets, right? And you need to optimize and automate your training process. GPU acceleration. So this is a big thing for Pytorch's success, and that is that it can run and optimize on GPU hardware, right? So there's a whole foundation module on integrating Pytorch code with GPUs, right? So this module just allows you to move your machine learning models and code to directly using GPU hardware, right? And this is very important for deep learning models and large data sets. So last couple, the Torch package. So this is the foundation of Pytorch. What are you going to find here? You're just going to find core functions for tensor operations, create, manipulation, and maths operations. So I've got a feeling maybe the Torch package is wrapped up in with the Tensors package, but we'll figure that out later. And the last one I'm going to mention is called torch.nn.functional, right? This is the functional module for Torch neural networks. And it basically contains a set of functions like activation functions, convolution neural network functions, pooling functions, etc., right? And you can use those across your Pytorch neural networks or whatever you're doing, right? So that's it for this intro. So the foundational modules you're going to come across are tensors, autograd, neural networks, loss functions, optimizers, data loader, GPU acceleration, torch, functional torch.nn or torch.nn.functional, right? So you've got 1, 2, 3, 4, 5, 6, 9, 9 key critical building blocks that make up the Pytorch library. That's it for this video.